everybody. You're here with me, Amaya, on the show, and it's a Friday morning. This is always good news. So we are starting off the day on the right foot, and everyone's looking forward to the weekend, I'm sure. And if you were lucky enough to get Friday as a holiday as well, that means you're looking at a long weekend here. So either way, it's great to have all of you joining us this morning for the program as well. And if you joined in for yesterday's program, then you would know that we had a small segment on how to protect yourself from lightning, which is a phenomenon that's becoming very common these days because of the storms that we're having, as well as the monsoon season that Sri Lanka is experiencing at the moment, especially in the southwest. And we had with us yesterday two lovely gentlemen. They're back with us on the show today as well to give you an idea about how you can protect yourself from lightning. And we have with us Professor J.R. Lucas. He is an emeritus professor attached to the University of Moratuwa with the Electrical Engineering Department. Good morning once again, Professor. It's nice to see you today as well.
It's very nice.
Very nice to meet you. And also we have with us an engineer attached to the Ceylon Electricity Board, and he is Engineer Kamal Illeperumal. Good morning to you too, Kamal.
Good morning.
So you're back here with us today, this morning as well, to continue the discussion that we had yesterday. Now, if you did miss the show yesterday, we spoke about how lightning occurs and how the lightning bolt forms, and we touched a bit on protection as well, but we'll go deeper into protection today. So before we go into the methods that we can use right now, I think you have some interesting historical facts about lightning protection, Professor.
Yeah. Most people think that lightning protection occurred about 200 years ago or maybe 300 years ago when Benjamin Franklin decided to fly a kite. I think most people have heard about that story.
Yeah.
But in actual fact, maybe 1,500 years earlier than that, Sri Lanka had lightning protection.
Ooh.
You might wonder how. Mahamansa says that the Ruanwali Sahib, when it was built, on the top of the kota in the
Chudamani, yes.
There is supposed to be lightning attraction properties, and inside the Ruanwali Sahib itself there are silver plates and copper plates which are supposed to be used for earthing. And according to what I've heard, long ago there's never been any lightning strikes on these stupas in Sri Lanka, probably because we had good lightning protection.
Oh, I see. So this is actually something that we don't have today, isn't it?
Yeah, really.
Not to the same degree, because unfortunately the Mahavansa did not record details. It only talks about that there were lightning protection, not about how exactly it was done.
But there are so many things, I guess.
I mean, this nowadays we get information that many of the tall structures getting struck by the lightning and all that. But as Professor mentioned, in the history we haven't heard much about lightning has struck on these stupas. Yeah, so that means we had a good protection.
It may be that lightning struck, but no damage was done, because when the stupas were built those days, special clay was used such that even the bricks could move. So if energy is dissipated, the bricks will just move without cracking.
There can be some mechanical forces along with the lightning, but still there's a provision for movement within the construction.
So all those were thought of. And I was
sort of like suspension, isn't it?
Yes, that's right.
Yeah.
That's kind of thing, some cushioning.
Cushioning is there, okay.
Because long ago, I think the only tall buildings were things like stupas or the pyramids. Pyramids, I understand, have been struck by lightning, but not the stupas.
Wow, so Sri Lanka.
Because those days, those were the only things that they needed to protect, because being religious, they were thought they must somehow protect this.
Wow.
A similar thing occurs in the ships. In the ancient ships, there's always what is called St. Elmo's fire, which occurs soon after a violent storm. They are like flames coming from the masts, but these flames never burn up the wooden mast. And because of that, it was thought of that St. Elmo was protecting the ships with this fire.
Oh, I see. Wow. Okay. So maybe we have different technology now to protect the tall buildings that we have and the structures that we have nowadays. So coming from here, what's the evolution of lightning protection? What do we have right now that people use commonly in the world today?
The basic lightning protection for buildings has not changed over the last 250 years.
Okay.
It is either the Franklin rod, named after Benjamin Franklin, or the Faraday cage, named after Michael Faraday.
Okay, so
So these principles are made use of in external protection. But of course, those days there was never computers and other things that we need protection.
of course, yeah, that's true. So I guess, Kamal, what we need to protect has now also increased.
That's the thing. So as Professor mentioned, so when it comes to lightning, there are two lightning things we are talking. The direct lightning. So a lightning come and strike somewhere, so direct hit.
Okay.
So, and the other thing is that we are talking about is the indirect lightning or the secondary light, the effects of lightning. So when a lightning strikes directly, it's a direct lightning, but when the lightning strikes and it goes into the earth, there can be side flashes. It can just jump onto the nearby places as well.
Okay.
For example, if it hits a tree, if somebody is closer by, some animal, a cow or a people are nearby, so while it goes to the earth, it can just jump out and side flashes and affect people or animal nearby.
That reminds me of something. If you are caught in a storm, you should never go and stand under a lone tree. That is the worst place to. You might get wet, but the lone tree is the one that is going to get stuck. And as Kamal mentioned, when lightning flows down, there can be side flashes to you, and you can get killed.
And that's the same, the very reason why people feel now there are many damages due to lightning, because those are called the secondary effects. Because while the lightning comes and goes to the ground, so you know that it's a huge electrical field, so it creates an magnetic field within that area. To a certain radius, it gets electromagnetized. So that's the very fundamental basics of electricity. In a kind of a changing electromagnetic field, any metal part is there will be a kind of a potential develop, a voltage develop in any of the metal things, any metallic thing, right? So those voltages that is induced can cause some damages to equipment as well. If somebody is touching that, that the human also can get some shock out of it. So those are called secondary effects. So on top of that, nowadays most of these electrical equipments carry a lot of electronics. Earlier days, mostly the electrical controls of the speed controls, some of the controls of these electrical equipments, they mostly use coils and capacitors kind of thing. But nowadays there are a lot of electronics, these transistors, diodes kind of things has come up. So those electronic things are very small things, you may know. So those are quite vulnerable for even a slight variation of kind of voltages kind of thing.
So long ago, the equipment that were there, even if the voltage changes by 10-20 volts, they may not have got damage. But when you talk about integrated circuits and things like that, a few volts is more than sufficient to damage it.
Everything.
So because of that, more people think that there are more lightning strikes now than before. The effects of lightning strikes are much more than before because the components that we use are much more vulnerable.
And further to that, nowadays you find the wires have gone everywhere in the country.
Of course,
so other than the earlier.
Propagated everywhere.
So, so the lightning also, if somewhere lightning struck, it can travel through kind of those wires or conductors through to many places. So that's kind of a perception within the people that lightning activity has gone up. and cause more damages. It's not the case basically. Because of that electromagnetization, there are secondary effects coming
And
into the
especially
picture.
since we live in a digital and electronic
That's
age,
Yeah.
that those effects can be seen more. So we'll speak about how you can save all the precious electronics, because all of us are very attached to all our electrical items. So stay with us. We'll be right back after the break with how you can protect yourself from these lightning strikes.